Hi there, I'm Sridhar Chandrasekharan, and I'm excited to present a study series on power transmission line construction. Drawing from my extensive career experience, this series is designed to provide practical and theoretical insights that can be directly applied to real-world projects. The primary goal of this study is to help engineers and managers deepen their understanding of transmission line construction, enhance the quality and efficiency of their work, take accountability and ownership of the tasks they manage. We began this journey by exploring the basics of electricity, how it's generated, its requirements, and its sources. From there, we've covered critical stages such as tendering, bidding, and project initiation. Moving forward, we'll delve into implementation, execution, and finally, project handover. Given the complexity of this topic, the content is divided into chapters released weekly. Along the way, we'll also integrate discussions on essential complementary areas, including engineering ethics, legal considerations, health and safety compliance, human resource management. These vital aspects will be seamlessly woven into our technical discussions to provide a holistic perspective. Each week, I'll release a new video featuring key technical topics, ethical dilemmas, and considerations, a thought-provoking quote to inspire meaningful reflection. Currently, we're in Chapter 7, focusing on the final stages of project management. There's still so much more to explore, so stay tuned for the upcoming chapters. Thank you for joining me on this journey of learning and growth. Disclaimer. Just a quick note. The content in these videos is meant for informational and basic educational purposes only. These videos aren't intended to provide professional advice or endorsements. This helps set the right expectations about the nature of what we're sharing, especially since we draw on material from various sources under the principle of fair use. We are now in Chapter 7, the final segment of project management. In the previous chapters, we covered several critical topics, including contract finalization, establish the project team, detailed project planning, selecting a project office and site organization, obtain necessary permits and approvals, arranging logistic, route survey, soil investigation, and detailed design. In this chapter, let us conclude the remaining topics to complete this comprehensive discussion on project management. In Chapter 6, we explored key aspects of project management, including obtaining necessary permits and approvals, arranging logistics, route survey, soil investigation, detailed design. In this chapter, we will conclude the remaining topics. Let's dive right in. Today's topics brief on project management. 10th, right-of-way acquisition, legal documentation, prepare and process easement agreements or land use permits, ensuring legal access to the areas needed for the transmission line. Community engagement, communicate with landowners and local communities to foster cooperation and address any concerns. 11th, procurement and resource mobilization. Material sourcing, order required materials, such as towers, conductors, and insulators, ensuring they meet project specifications. Equipment mobilization, arrange for cranes, trucks, drilling rigs, and other heavy machinery needed for construction tasks. Supplier and subcontractor selection. Engage with suppliers and subcontractors for specialized tasks, such as civil works, foundation installation, and material supply. 12th, implement safety and environmental protocols, safety training. Conduct training sessions on safety protocols, hazard recognition, and emergency response procedures. Environmental protections. Implement measures to minimize environmental impact, such as erosion control, dust management, and noise reduction. 13. Documentation, submission, and approvals. Project documentation. Submit all required documents for project approval, including design plans, safety protocols, environmental assessments, and compliance reports. Regulatory approvals. Obtain final regulatory sign-offs to proceed with construction, ensuring that all legal requirements are fulfilled. 14th construction phase, execution. Once the above preparatory steps are in place, the company can begin the construction phase. This includes activities like site preparation, foundation work, tower erection, and conductor stringing. We will cover the specifics of these construction activities in the later part of our chapter. Now let us understand the topics in details. 10th topic on project management is right-of-way acquisition. Transmission line. Right-of-way is a critical component in the planning and execution of transmission line construction. The ROW involves securing and clearing a designated corridor along the transmission line route where towers, foundations, and conductors will be installed. Since ROW acquisition and clearance often fall under the client's responsibility, it is essential for the contractor to coordinate closely with the client to ensure that the ROW is ready as per the project schedule. Effective ROW management helps prevent delays, allows for smooth construction progress, and minimizes disruptions. Here's a detailed look at the ROW coordination process and the contractor's role. 1. Understanding the right-of-way requirements. 2. Coordination with the client for ROW clearance. 3. Scheduling ROW clearance with construction activities. 4. Addressing ROW challenges and obstacles. 5. Ensuring regulatory compliance in ROW clearance. 6. Documentation and reporting. 7. Preparing for construction following ROW clearance. Let's dive into the topic of right-of-way acquisition and explore its aspects step by step. 1. Understanding the right-of-way requirements. Purpose of the ROW. The ROW provides the physical space needed for construction, operation, and maintenance of the transmission line. It includes clearance zones around towers and conductors to ensure safety and maintain access for future repairs. Width and specifications. The ROW width depends on the transmission line voltage, tower design, and safety requirements. Higher voltage lines require wider corridors to prevent electrical hazards and allow safe maintenance access. ROW requirements typically include clearance from buildings, maintain safe distances from residential, commercial, and industrial structures. Vegetation control, clear trees, shrubs, and other vegetation to prevent interference with the line and reduce the risk of fires or outages. Access roads include access roads within the ROW for equipment, material transport, and personnel movement. 2. Coordination with the client for ROW clearance. Client's responsibility. In most cases, the client, such as a government agency or utility company, is responsible for acquiring and clearing the ROW. This involves negotiating with landowners, obtaining legal easements, and addressing regulatory requirements. Initial ROW meetings. Schedule initial meetings with the client to understand their ROW acquisition plan, timeline, and any potential challenges. This meeting should cover ROW acquisition status, review the progress of securing land rights, and any outstanding negotiations with landowners. Clearance scope and responsibilities. Clarify the client's responsibility for vegetation clearance, obstruction removal, and relocation of existing structures. Regulatory requirements. Ensure that the client is addressing all regulatory requirements related to ROW, including permits, environmental considerations, and community consultations. Follow-up and progress monitoring. Regularly follow up with the client to track ROW clearance progress. Effective follow-up helps the contractor stay informed and adjust project schedules as needed. Weekly or bi-weekly check-ins. Establish a regular communication schedule with the client's ROW team to discuss progress, upcoming milestones, and any issues that may impact the project timeline. Reporting and documentation. Request progress reports, maps, and documentation of cleared ROW sections to maintain an accurate record of ROW readiness. Three, scheduling ROW clearance with construction activities, aligning ROW with the construction schedule. The contractor needs to ensure that ROW clearance aligns with the construction schedule, allowing crews to access each section of the route on time. This coordination minimizes idle time, resource delays, and potential costs associated with schedule changes. Phased approach to ROW clearance. In large transmission line projects, ROW clearance may occur in phases based on priority areas. For example, foundation preparation. Ensure ROW is cleared first in areas where foundation work is scheduled to begin. Tower erection. Clear ROW ahead of tower erection activities to allow equipment and personnel access. Conductor stringing. The ROW corridor should be fully cleared before conductor stringing to prevent interference from trees or structures. Adjusting for delays or changes. Be prepared to adjust construction activities if ROW clearance is delayed. This may involve reallocating resources, resequencing tasks, or focusing on other project areas until the ROW is ready. Four, addressing ROW challenges and obstacles. Dealing with landowners and community concerns. The client is usually responsible for negotiating with landowners, but the contractor may assist by providing technical information or addressing specific concerns related to construction activities. Landowner coordination. Work with the client to communicate the project's impact and resolve any issues raised by landowners. This might involve meetings, providing project details, and discussing compensation, managed by the client. Community engagement. Support the client's community outreach efforts by offering construction-related insights or participating in community meetings if necessary. Environmental and cultural considerations. In some cases, the ROW may pass through environmentally sensitive areas or cultural heritage sites. The client must comply with all environmental regulations and obtain the necessary permits. Environmental impact mitigation. The contractor can help the client identify environmental mitigation measures, such as erosion control or vegetation management plans, based on the ROW's specific characteristics. Cultural and heritage sites. If the ROW includes sites of cultural significance, coordinate with the client on any special protocols or requirements needed to protect these areas. Removal of physical obstructions. If buildings, structures, or other obstructions are present in the ROW, The client is generally responsible for their removal or relocation. The contractor may need to provide input on how these obstructions affect construction plans and recommend solutions. Five, ensuring regulatory compliance in ROW clearance. Review of permits and approvals. Work with the client to verify that all necessary permits for row clearance are in place. These may include environmental permits, building permits, or special permissions for working in protected areas. Adherence to environmental standards. Ensure that row clearance activities comply with environmental standards, particularly in terms of vegetation management and erosion control. For example, selective clearing. Implement selective clearing practices that minimize environmental disruption and maintain biodiversity where possible. Erosion control. Measures. Develop plans to prevent soil erosion in areas where vegetation has been removed. This may involve using silt fences, mulch, or native plants to stabilize the soil. Safety standards. Confirm that the ROW clearance process adheres to safety regulations. The client should conduct a hazard assessment and implement safety protocols to protect workers, the public, and the environment. Six, documentation and reporting. Progress. Documentation. Document each stage of ROW clearance with detailed reports, maps, and photographs. These records are essential for tracking progress, addressing issues, and maintaining accountability. Reporting to the client. Provide regular updates to the client on ROW readiness, highlighting any challenges, risks, or areas where additional support is needed. Effective reporting helps the client stay informed and take timely action as required. Final row clearance verification. Before starting construction in each segment, conduct a final verification with the client to confirm that the ROW is fully cleared and accessible. This confirmation reduces the risk of unexpected delays or disruptions. Seven, preparing for construction. Following ROW clearance. Site access planning. Once the ROW is cleared, finalize access points, staging areas, and storage locations along the ROW. Ensure that all required access roads are in place to facilitate the smooth movement of materials and equipment. Mobilization of construction teams. With the ROW ready, coordinate the mobilization of construction crews to begin foundation work, tower erection, and conductor stringing. Having a cleared ROW allows construction to proceed efficiently and on schedule. Ongoing ROW maintenance. During construction, maintain the ROW by controlling vegetation regrowth, monitoring erosion, and keeping access roads clear. Regular maintenance ensures that the ROW remains safe and functional throughout the project. Next, let us pass on to the 11th topic of project management is procurement and resource mobilization. It is vital steps in preparing for transmission line construction. This phase involves sourcing essential materials, mobilizing necessary equipment, and engaging suppliers and subcontractors. Efficient and well-coordinated procurement and mobilization ensure that all resources are available on-site when needed, enabling the project to proceed smoothly and according to schedule. 1. Material sourcing. 2. Equipment mobilization. 3. Supplier and subcontractor selection. 4. Establishing a resource mobilization plan. 5. Ensuring compliance with safety and regulatory standards. 6. Ongoing communication and coordination. Let's dive into the topic of procurement and resource mobilization and explore its aspects step by step. 1. Materials sourcing. Identifying material requirements. Based on the engineering designs and specifications, compile a list of all necessary materials, including towers, conductors, insulators, and accessories. The list should specify quantities, technical specifications, and quality standards for each item. Ordering major components. Place orders for primary transmission line components, ensuring they meet the project's technical specifications. Key items include towers. Order tower components based on the approved designs, such as lattice towers, monopoles, or guide towers. Specify corrosion-resistant coatings and finishing treatments as required by the project. Conductors. Choose conductors that align with the project's electrical requirements. This may include ACSR, AAAC, or ACCR conductors, depending on the transmission voltage and environmental factors. Insulators. Order insulators based on the line voltage and environmental conditions. Ensure they are durable and resistant to factors like pollution, moisture, and UV exposure. Tower and conductor accessories. Include accessories such as clamps, spacers, vibration dampers, and connectors. These accessories must match the technical specifications and support the safe, reliable operation of the line. Supplier selection and competitive bidding. Identify and evaluate potential suppliers based on their ability to meet technical specifications, delivery timelines, and cost-effectiveness. Follow a competitive bidding process to select reputable suppliers and negotiate favorable terms. Quality assurance. Establish quality assurance criteria for suppliers. This may involve inspecting materials before shipping, reviewing certifications, and performing material tests to confirm compliance with project standards. Tracking and delivery coordination. After orders are placed, set up a tracking system to monitor delivery timelines. Coordinate with suppliers to ensure that materials arrive on site according to the project schedule. Timely deliveries help prevent delays and maintain the construction timeline. 2. Equipment mobilization. Equipment assessment and sourcing. Assess the equipment needed for construction tasks, such as tower erection, conductor stringing, foundation work, and other activities. Equipment requirements typically include heavy machinery, mobilize or acquire cranes, excavators, bulldozers, and other heavy machinery required for foundation excavation, tower assembly, and erection. Specialized equipment. Arrange for specialized equipment such as tensioners, pullers, and reel winders for conductor stringing. These tools are essential for maintaining proper tension and alignment during installation. Construction vehicles. Ensure vehicles like trucks, flatbeds, and trailers are available for transporting materials, tools, and equipment around the site. Foundation equipment. If foundation installation involves pile driving, augers, or concrete pouring, ensure these machines are available and in good working condition. Mobilizing from other sites. In some cases, contractors may have equipment available at other project sites. Coordinate the transfer of this equipment, ensuring it is transported safely and arrives in working condition. Mobilizing existing equipment can reduce costs and expedite resource availability. Purchasing or leasing equipment. If the necessary equipment is not readily available, consider purchasing or leasing from local providers. Leasing can be cost-effective, especially for equipment only needed for specific project phases. Logistics and transportation coordination. Plan the logistics for moving equipment to the project site, especially for heavy or oversized items. Coordinate with transportation providers, obtain necessary permits, and arrange for escort vehicles if needed. Inspection and maintenance. Upon arrival at the site, inspect all equipment for operational readiness. Perform any required maintenance, repairs, or calibration to ensure safe and efficient operation throughout the construction phase. 3. Supplier and subcontractor selection. Engaging local suppliers. Identify local suppliers for civil-related materials such as aggregates, cement, and reinforcement bars. Using local suppliers can reduce transportation costs, support the local economy, and improve delivery timelines. Quality and reliability. Evaluate local suppliers based on the quality of their materials, reliability, and ability to meet project specifications. Obtain samples or certifications if necessary to verify material quality. Supply contracts. Establish contracts with suppliers, outlining the terms, quantities, delivery schedules, and quality standards for each material. Ensure that suppliers understand project requirements and have the capacity to meet demand. Subcontractor selection for specialized tasks. Some project tasks, such as foundation installation, civil works, and tower erection, may require specialized skills or equipment. Engage subcontractors with expertise in these areas to support project delivery. Civil works. Subcontractors. Hire subcontractors for tasks such as earthworks, road construction, and site preparation. These tasks are essential for preparing the site for foundation and tower construction. Foundation installation. Engage subcontractors with experience in foundation construction, especially if the project involves challenging soil conditions or complex foundation types, e.g., pile foundations or rock anchors. Material supply and erection. Identify subcontractors who specialize in erecting transmission towers and stringing conductors. Ensure they have the necessary certifications, equipment, and skilled personnel to complete these tasks safely. Competitive bidding and evaluation. Conduct a competitive bidding process to evaluate potential subcontractors and select the most qualified and cost-effective candidates. Consider factors such as experience, capacity, safety record, and ability to meet project timelines. Subcontractor contracts and agreements. Draft contracts with selected subcontractors, clearly defining the scope of work, timelines, payment terms, and performance expectations. Specify quality standards, safety protocols, and compliance requirements to ensure subcontractors meet project expectations. Four, establishing a resource mobilization plan. Developing a mobilization schedule. Create a detailed mobilization schedule that aligns with the project timeline. The schedule should include delivery dates for materials, arrival times for equipment, and start dates for subcontractor tasks. Phased mobilization. If the project is large or complex, consider mobilizing resources in phases. For example, foundation materials and equipment can be mobilized first, followed by tower erection resources and conductor stringing tools. Coordinating with the project team. Work closely with project managers, engineers, and site supervisors to ensure that mobilization activities align with the construction schedule. Effective coordination helps prevent delays and ensures that all necessary resources are available when needed. Resource tracking and inventory management. Implement a tracking system to monitor material deliveries, equipment arrivals, and subcontractor performance. This system provides real-time visibility into resource availability and helps identify potential delays or issues. Logistics and storage planning. Arrange for storage areas on-site for materials and equipment. Designate secure storage locations for sensitive items, such as conductor accessories and tools, and plan for temporary facilities to store larger items like tower sections and foundation components. 5. Ensuring compliance with safety and regulatory standards. Safety standards for equipment and materials. Verify that all procured materials and mobilized equipment meet safety and regulatory standards. Conduct safety inspections, maintain equipment certifications, and ensure that subcontractors follow safety protocols. Environmental and regulatory compliance. Ensure that procurement and mobilization activities adhere to environmental regulations. For example, transporting heavy equipment may require permits, and material storage may need to comply with environmental guidelines. Quality control and inspections. Implement quality control measures to inspect materials and equipment upon arrival. This includes verifying material specifications, checking equipment functionality, and documenting compliance with project standards. 6. Ongoing communication and coordination. Supplier and subcontractor. Communication. Maintain regular communication with suppliers and subcontractors to monitor progress, address issues, and ensure that they are on track to meet project timelines. This communication helps manage expectations and facilitates problem-solving. Reporting to the project team. Provide updates to the project team on material deliveries, equipment mobilization, and subcontractor performance. Keep the team informed of any delays or changes, allowing them to adjust plans as needed. Stakeholder engagement. Engage with the client, regulatory agencies, and local authorities throughout the procurement and mobilization process. Transparency with stakeholders helps build trust and ensures that the project meets all requirements. The procurement and resource mobilization phase is crucial for ensuring that all necessary materials, equipment, and personnel are available on-site to support transmission line construction. By carefully selecting suppliers, sourcing quality materials, mobilizing specialized equipment, and engaging reliable subcontractors, the project team can maintain momentum, adhere to schedules, and meet quality standards. Effective resource management, coupled with ongoing communication and compliance with safety and regulatory standards, sets the foundation for a well-organized and successful construction project. This brings to an end of 11th topic of procurement and resource mobilization on project management. 12th topic on project management is implementing safety and environmental protocols. Implementing safety and environmental protocols is a fundamental aspect of transmission line site construction. It ensures the well-being of workers, the protection of local ecosystems, and compliance with regulatory standards. Effective safety and environmental protocols help prevent accidents, minimize environmental impact, and support sustainable construction practices. 1. Risk assessment and hazard identification. 2. Safety training for workers. 3. Fall protection and working at heights. 4. Fall protection and working at heights. 5. Electrical safety and lockout, tag out, LOTO. 6. First aid and emergency response. Here's a detailed breakdown of the establishing a comprehensive safety plan and environmental measures to be taken during transmission line site construction. 1. Risk assessment and hazard identification. Conduct a thorough risk assessment to identify potential hazards associated with transmission line construction, such as working at heights, heavy equipment operation, electrical risks, and environmental exposures. Site-specific risk assessment. Tailor the assessment to the specific project location, considering factors such as terrain, weather conditions, and nearby infrastructure. Hazard control. Measures. Develop control measures for each identified risk, prioritizing hazard elimination, engineering controls, administrative controls, and personal protective equipment, PPE. 2. Safety training for workers. Provide comprehensive training to all personnel on site to ensure they are aware of potential hazards, understand safety protocols, and know how to respond to emergencies. PPE training. Train workers on the proper use, care, and maintenance of PPE, such as hard hats, gloves, harnesses, and respiratory protection. Ensure that PPE is provided for specific tasks, such as climbing towers, handling chemicals, or working with heavy machinery. Equipment and tool safety. Conduct training sessions on the safe operation of heavy machinery, tools, and specialized equipment like tensioners, pullers, and cranes. Equipment operators should be certified, and all personnel should be familiar with the operation protocols for the tools they use. Three, fall protection and working at heights. Since transmission line construction often involves working at heights, implement stringent fall protection measures. Fall protection systems. Install harnesses, guardrails, safety nets, and lifelines where necessary. Ensure that workers are trained in fall protection procedures and inspect all equipment regularly for signs of wear. Height-specific training. Workers assigned to tasks that require climbing towers or working at elevated heights should undergo specialized training in safe climbing techniques, anchor point selection, and emergency descent procedures. 4. Electrical safety and lockout, tagout, LOTO. Since electrical components are integral to transmission line construction, enforce strict electrical safety protocols. LOTO procedures. Implement lockout, tagout procedures to ensure that electrical circuits are de-energized before any maintenance or repair work. All workers should be trained in LOTO procedures to prevent accidental energization. Safe working distances. Establish minimum safe distances for workers working near energized components. Use insulated tools and provide training on recognizing and avoiding electrical hazards. Five, first aid and emergency response. Equip the construction site with first aid kits, emergency response equipment, and an emergency response plan tailored to potential risks on site. On-site first aid stations. Set up first aid stations in accessible locations on site. Ensure that trained first aid responders are available during all shifts. Emergency evacuation procedures. Develop evacuation procedures for different scenarios, such as fire, medical emergencies, or severe weather. Conduct regular drills to ensure all personnel are familiar with evacuation routes and assembly points. 13th topic on project management is implementing environmental protection measures. Implementing safety and environmental protocols is a multifaceted effort that involves assessing risks, training workers, and establishing monitoring systems to ensure compliance with safety and environmental regulations. By integrating safety practices, such as fall protection and electrical safety, with environmental measures, such as erosion control and habitat protection, transmission line construction can proceed with minimal risk to workers and minimal impact on the surrounding environment. These protocols help the project maintain regulatory compliance, safeguard workers and local communities, and contribute to the sustainable development of essential infrastructure. 1. Environmental impact assessment. 2. Vegetation management and habitat protection. 3. Waste management and pollution prevention. 4. Noise and dust control. 5. Safety inspections and audits. 6. Environmental monitoring. 7. Documentation and reporting. 8. Community engagement and communication. 9. Worker awareness and environmental responsibility. Let's dive into the topic of implementing environmental protection measures and explore its aspects step by step. Environmental impact assessment. Prior to construction, conduct an environmental impact assessment to identify potential impacts on local ecosystems, water resources, soil, and wildlife. Use the findings to develop mitigation strategies that minimize harm to the environment. Compliance with regulatory requirements. Ensure that all environmental protocols align with local, regional, and national regulations. Obtain necessary environmental permits before beginning construction. Erosion and sediment control. Prevent soil erosion and sediment runoff by implementing measures such as silt fences, sediment basins, and erosion control blankets. This helps maintain soil stability, especially in areas with steep slopes or loose soil. Two, vegetation management and habitat protection. Transmission line construction may require clearing vegetation, but it's crucial to do so in a way that minimizes impact on local flora and fauna. Selective clearing techniques. Use selective clearing methods to remove only the vegetation necessary for the row. This helps preserve surrounding ecosystems and reduces the risk of soil erosion. Habitat protection. Measures. Identify and protect habitats of endangered or protected species along the transmission line route. Implement buffer zones and avoid construction activities during sensitive periods, such as nesting or breeding seasons. Three, waste management and pollution prevention. Develop and implement a waste management plan to properly handle and dispose of construction debris, hazardous materials, and other waste. Segregation and disposal. Separate waste materials into categories such as recyclable, non-recyclable, and hazardous waste. Dispose of each category according to regulatory requirements and use licensed waste disposal companies for hazardous materials, spill prevention and control. Store fuels, oils, and chemicals in secure, designated areas to prevent leaks and spills. Provide spill kits on site and train personnel in spill response procedures. In case of a spill, contain the substance immediately, clean it up safely, and report it to relevant authorities if required. Four, noise and dust control. To reduce the impact of construction on nearby communities, implement measures to control noise and dust emissions. Dust suppression. Use water sprays or dust suppression agents to minimize dust from construction activities, particularly during dry weather. Cover loose materials during transportation and limit vehicular speed on unpaved roads. Noise reduction. Schedule high-noise activities during times that minimize disturbance to nearby residents. Use noise barriers or mufflers on heavy machinery, and ensure equipment is maintained to reduce noise output. Five, safety inspections and audits. Conduct regular safety inspections to ensure that all protocols are being followed and that equipment is in good working condition. Daily safety checks. Designate a safety officer to perform daily safety checks on equipment, PPE, and work areas. Address any safety concerns immediately to prevent accidents. Monthly audits. Schedule monthly audits to review safety documentation, training records, and incident reports. Use audit findings to improve safety practices and address recurring issues. Six, environmental monitoring. Implement ongoing environmental monitoring to track impacts on soil, water, and air quality. This helps identify any issues early and allows for prompt corrective action. Soil and water testing. Conduct periodic soil and water testing around the construction site to detect contaminants. If contamination is found, take immediate steps to mitigate the impact and prevent further pollution. Air quality monitoring. Install air quality monitors to measure particulate levels and emissions. This is especially important in areas close to residential communities to ensure that construction activities do not adversely affect local air quality. Seven, documentation and reporting. Maintain detailed records of safety and environmental activities, including training sessions, incident reports, and inspection logs. Safety logs and incident reports. Document all safety incidents, near misses, and corrective actions taken. This information helps identify trends and enables continuous improvement. Environmental compliance reports. Prepare environmental compliance reports to demonstrate adherence to regulatory requirements. These reports should include monitoring data, mitigation measures, and any actions taken to address environmental issues. Eight, community engagement and communication. Engage with local communities to inform them about the project, expected impacts, and measures in place to protect their safety and the environment. Public meetings and information sessions. Hold public meetings to provide information on construction activities, address concerns, and gather feedback. Keep the community informed about project progress and potential impacts. Complaint resolution mechanism. Establish a system for residents to report concerns such as noise or dust complaints. Ensure timely responses to community feedback to maintain positive relations with stakeholders. Nine, worker awareness and environmental responsibility. Foster a culture of environmental responsibility among workers by including environmental protection in training programs. Environmental awareness training. Provide training on waste management, pollution prevention, and the importance of protecting local ecosystems. Encourage workers to report any environmental issues or hazards they observe on site. Safety and environmental incentives. Consider implementing incentive programs that reward workers for following safety and environmental protocols. Recognizing positive behavior reinforces the importance of compliance and sets a standard for others. In addition to the other project management topics, it is essential to consider the importance of the following aspects before commencing construction activities. like civil works, test reports, design mix, method statement for all the site activities, supply of tower materials, conductor, insulator, and accessories test reports. Let us understand first civil works test reports, design mix, and approvals. Civil materials must be tested according to the specified design standards at a client-approved laboratory, covering materials such as aggregates, cement, rebar steel, and water. After the aggregates pass their tests, a concrete design mix is prepared in the lab to meet project requirements, with strength testing conducted over specified curing periods. Upon approval of these test results, the client then approves the design mix for on-site implementation. It is essential that this process is completed prior to starting foundation activities. We will cover this topic in detail in our construction chapter. Two, method statement for all the site activities, submission, and approval. For each construction activity for all activities, a detailed method statement outlining the working methodology, safety procedures, and quality standards must be submitted to the client or consultant. After review and any necessary revisions, the method statement is approved for use on site. Any deviations from the approved methodology must be documented, amended, and reapproved before implementation. Otherwise, the approved method statement should be strictly followed during on-site activities. We will cover this topic in detail in our construction chapter. Three, supply of tower materials, conductor, insulator, and accessories test report, submission and approval. All materials supplied for the project, including tower components, conductors, insulators, and accessories, must undergo type testing in accordance with relevant standards and specifications. A detailed methodology for these tests must be submitted to the client or consultant for approval prior to execution. Once approved, the testing process will proceed, with consultants witnessing the tests at the respective manufacturing facilities. Only after this approval can mass production and delivery to the project site commence. We will cover this topic in detail in our construction chapter. Fourteenth topic on project management is construction phase execution. The site construction activities will be explored in detail in our upcoming studies. We will cover each phase, starting from route, detail, and check surveys to excavation, stub setting, foundation work, backfilling, tower protection, tower assembly, and erection. In addition, we will examine tower inspections, and for the stringing phase, we will go through conductor paying out, sagging, installation of earth wires, OPGW, final checks, line energization, and ultimately, handing over and maintenance. Each activity will be discussed comprehensively, along with related processes to ensure a thorough understanding of the entire transmission line construction process. We will cover this topic in detail in our construction chapter. In this chapter, we have completed the remaining topics on project management, covering essential areas such as obtaining necessary permits and approvals, arranging logistics, route survey, soil investigation, detailed design, right-of-way acquisition, procurement and resource mobilization, implementing safety and environmental protocols, documentation submission and approvals, and an overview of the construction phase execution. With this, we conclude our focus on project management. Some of these topics will be revisited in greater detail in our upcoming sections on construction activities. In our study program, we have consistently emphasized the principles of professional ethics, covering all related topics in the previous chapters. Starting from Chapter 6, we have introduced legal compliance in corporate business for professionals and staff. Each week, we will delve into different aspects of this topic. This new subject offers valuable insights and practical knowledge, which we believe will be highly beneficial for all our viewers. Legal compliance refers to the adherence to laws, regulations, standards, and ethical practices that govern corporate activities. For corporate professionals, understanding and following these requirements is essential for maintaining the integrity, reputation, and success of both the individual and the organization. Legal compliance is a critical component in corporate governance and business operations, helping professionals navigate complex regulatory environments, avoid legal issues, and ensure ethical business practices. Let us understand the aspects of legal compliance for corporate professionals. These are following topics we will be covering in our chapters. 1. Understanding relevant laws and regulations. We have completed in Chapter 6. 2. Corporate governance and ethical standards. This topic we will cover in this chapter, and the balance will be covered in our upcoming chapters. 3. Compliance with employment laws. 4. Data privacy and protection. 5. Anti-corruption and anti-bribery laws. 6. Environmental compliance. 7. Financial and tax compliance. 8. Intellectual property, IP compliance. 9. Implementing legal compliance in the workplace. Second topic on legal compliance: corporate governance and ethical standards. It refers to the principles, practices, and policies that guide how businesses are directed and controlled, ensuring accountability, fairness, and transparency. These frameworks promote ethical behavior and safeguard the interests of stakeholders, including shareholders, employees, customers, and the community. Corporate governance establishes the rules and practices for decision-making, ensuring that a company operates in a responsible and accountable manner. Board of Directors ensures oversight and strategic direction. Transparency in clear communication of business performance and decisions. Accountability in ensuring management acts in the best interest of stakeholders. Stakeholder engagement, addressing the interests of all parties involved in or affected by the company, builds trust with investors and the public, reduces risks of fraud and mismanagement, enhances long-term sustainability and profitability. Ethical standards in business refer to the moral principles that guide behavior, ensuring fairness, honesty, and respect in all corporate dealings. And the core principles are integrity, acting with honesty and adhering to moral values. Fairness, ensuring equity in decisions and actions. Respect, treating employees, customers, and partners with dignity. Responsibility, owning up to actions and their consequences. And the implementation are establishing a code of ethics for employees and leadership, conducting regular training on ethical practices, enforcing zero tolerance for unethical practices like bribery, fraud, or discrimination. Corporate governance and ethical standards ensure that businesses operate responsibly, maintain stakeholder trust, and align with societal expectations. Together, they create a foundation for long-term success and sustainability. Today's quote is from Honoré de Balzac. Laws are spider webs through which the big flies pass and the little ones get caught. The quote suggests that laws, while intended to regulate and control behavior, often work unevenly depending on the social, economic, or political power of individuals. In this analogy, the spider webs represent the legal system, while the big flies are those with power, wealth, or influence who can escape punishment, and the little ones are ordinary people who get entangled in the legal system and face consequences more readily. As we wrap up our session, I encourage you to subscribe and hit the bell icon so you won't miss any of our upcoming chapters. It's your gateway to mastering transmission line supervision. That brings us to the end of today's Chapter 7, Concluding Project Management. Next time, we'll dive into the fascinating topic of appointing consultant or consultancy. Until then, take care and thank you for watching.